All right, number 34.
Yay, 34.
C is 96 degrees, A is 7, B is 15, and I'm going to use the area formula. Somebody tell me what the area formula was.
I wrote it down somewhere in my notebook.
It's like half a sine, something.
Just area equals 1/2
AB sine C.
Yeah.
AB sine C.
I love you.
Okay, so it's always 1/2. All right, homework problems now are going to be, and I just won't even go over this. 27, I don't know if I gave you that one yesterday, 31, 35, and 39. If we're going to talk, I am not joking. I will just give you these problems and there will be a quiz tomorrow. Okay? I'm really tired of it because I'm up here trying to teach this stuff, but yet we just keep talking. And then you're going to expect me to reteach it when you don't understand. And that's not happening. Okay? If everybody's listening and paying attention and we don't understand, I don't mind going over something again. But if we're just going to talk, I do mind. Okay? So are we ready to listen and I'll do this problem? Okay. So, area is 1/2 our two side lengths, so 7 times 15 times the sine of 96. Okay, remember we're always in degree mode for this stuff. So you can type that in your calculator and tell me what our area is. And we're not actually given units, so you don't have to worry about it.
I got 52.2.
52.2.
But I don't know if that's right, so I wouldn't write it down yet.
34? Yep, that's right. All right, 36. B is 60 degrees, A is 19, and C is 14. So what goes here, or what is the area formula for this one?
Area equals AC sine B.
1/2 AC sine B. Okay, so it's always 1/2 your two side lengths times the sine of the angle that you're given. Okay, I don't think your book tries to trick you and ever give you other pieces where you have to find the other. No, they're good. They don't ever try to trick you, so.
Can you scroll up for just a second?
Yeah. So we've got 1/2 times 19 times 14 times the sine of 60.
I got 115.
Yep. 115. Okay, it doesn't specify, so if you guys want to round to the nearest whole number, that's fine. Definitely not more than one decimal place, though.
So when you're doing area, whichever degree you have, you put it in for sine, or,
Yeah, whatever angle you're given, you put it in for sine.
and then the extra you can multiply them.
Yes, and take half of that. Now, obviously, when we get to the quiz that I currently have scheduled for next Wednesday, okay, it could move to Friday next week, okay, but I'm also not trying to give you everything the day before spring break, which is what I'm suspicious is going to happen with most of your classes, okay? So, by that point, we will have another area formula that goes with the next section, okay? So, you will have to know which one you're using, okay? But with that one, it either gives you, I think they give you all three sides for that one, and you have to use the other formula for it. So just make sure you pay attention to which case we have. Right now we only have one case where it gives you two sides and an angle, okay? But just be aware that next section we are getting another one that goes with it, okay? Do we need to see another area one, or are we okay?
So,
I have a question about the triangles we're doing.
Okay.
You can ask your question.
okay, you said that when you have the sides, it doesn't matter what side you have. Like if you had sides A and B, you would just do half times A times B, right?
Yeah, and then you'd have to have angle C then for this particular formula. Which your book isn't going to trick you and try to give you like a side and it's not going to give you a buddied pair. for these problems. They're not going to be mean like that. And if by some chance I happen to do that on your quiz, it's a typo, so just let me know.
Sounds good, thank you.
Berkeley, what's your triangle question?
Okay. So are we doing two-dimensional triangles? Like in trig, are we doing three-dimensional?
2.
Okay.
Technically, I think they're just 1.
So in geometry,
Well, no.
we learned that if there was a line and then you had the angle, okay, say you have a straight line and there's a straight line coming out of the straight line and you had the angle of the straight line. So yeah, and then you had the angle of one of the things. So say that's like 21 or something. I don't know. If you subtract that by 180, shouldn't that give you the other angle?
That gives you this one.
Yeah.
Yes.
So
But that's not relevant for our triangles.
So it doesn't work for the triangle you're doing?
No, because we would want this one over here.
Because yesterday we were doing a problem and we used reference angles instead of subtracting. You know what I'm talking about?
Well, yeah, I mean, it's still the same thing. But it's not, like, yes, these two right here add up to be 180. But this angle is not relevant for what we're doing. We need the whole triangle and then we need the smaller one.
Okay, thank you.
So we need this one and then this one. And these two are reference angles.
Because yesterday we did 180 minus 42 on the triangle, which was the reference angle, but I thought it would equal 0. It's fine. I understand.
All right, so 31, 35, and I'm not gonna make you do 39. Just 31 and 35. Added on to what you had before for the last couple days.
31, 35, and what were the other ones?
It's
I don't know.
19. It's like
It's
19.
3,